Today we will solve some examples from exercise 3.3, which is based on the integration by parts and its corollary. So let us begin. Evaluate the following: x square into log of x dx. So let I is equal to x square into log of x. Now, whenever we are going to use the by parts, we must think of LIATE rule. L stands for logarithmic, I stands for inverse trigonometric, A stands for algebraic, T stands for trigonometric, and E for exponential. Okay, so the first function must be logarithmic. So log x is the first function, and the second function is x square. So what is the by parts? Keep first function as it is, integration of the second function minus integration in bracket derivative of the first function into integration of the second function. So integration of x square is x cube upon 3 minus in d by dx of log x is 1 upon x into integration of x square is x cube upon 3 dx. So here after cancelling this x, you will get x square upon 3 dx. Now as 1 upon 3 is a constant, so we can take outside. So here there is an integral of x square only, and its integral is given by x cube upon 3 plus c. So I is equal to x cube upon 3 into log of x minus x cube upon 9 plus c is the integration of the given function. Now the next example is x cube log of x dx, its integral. So again use LIATE. Log x is the first function and x cube is the second function. So first function as it is, integration of the second function minus integration of the derivative of the first function, integration of the second function. So here the integration of x cube is x raised to 4 upon 4. In both this case, the integration is x raised to 4 upon 4. And the derivative of log x is 1 upon x. So here this x will cancel and will be integration of x cube. 1 upon 4 is common. Now its integral x cube. Its integral is given by x raised to 4 upon 4. X is to 4 upon 4. So multiply this 4 into 4 is 16, or you may take 1 upon 4 common from each of this. You will get x is to 4 upon 4 log x minus 1 by 4, or x is to 4 upon 16 times 4 log x minus 1 plus c is the integration of the given function. Integration of x square into sine 3x dx. I is equal to integration of x square into sine 3x, LIATE, because algebraic comes first and then trigonometric. LIAA is algebraic and then trigonometric, so I have written like this. So using the by parts, first function as it is, integration of the second minus integration of d by dx of the first function into integration of the second function. So sine 3x, its integral is cos minus cos 3x upon 3, and derivative of x square is 2x. This minus and this minus will become plus, and this 2 upon 3 I can take common. So 2 upon 3 integration of x cos 3x. Again use further by parts to evaluate this integral of first function as it is, integration of the second minus d by dx of the first function into integration of the second function. Now the integration of cos 3x is sine 3x upon 3, and the derivative of x is 1, and integration of cos 3x is sine 3x upon 3. So I1 is equal to x sine 3x upon 3 minus 1 upon 3 integration of sine 3x. But integration of sine 3x is minus cos 3x upon 3. So again this minus minus will become plus, and yeah, you will get the integral 1 upon 3 times x sine 3x plus 1 upon 9 cos 3x plus c1. Use this I1 in this equation to get the final answer. I is equal to minus x square cos 3x upon 3 plus 2 upon 3 times 1 upon 3x sine 3x plus 1 upon 9 times cos 3x plus c. Multiply this by 2 by 3, you will get this the required answer. Now moving further, the next example is x tan inverse of x. Now how to solve it? LIATE. The inverse trigonometry must be first function and then the algebraic function. So first function as it is integration of the second minus integration derivative of the first function into integration of the second function. Now derivative of tan inverse of x is 1 upon 1 plus x square and integration of x is x square upon 2. Okay, so here you will get 1 upon 2 common, integration of x square upon 1 plus x square dx. So minus 1 upon 2 integration of 1 plus x square minus 1 upon 1 plus x square dx. So I is equal to x square by 2 tan inverse of minus 1 upon 2 times integration of 1 plus x square minus 1. So we are adjusting 1 here. Then we will divide this 1 plus x square by this 1 plus x square and minus 1 upon 1 plus x square. Here I will get 1 dx and here its integral is given by tan inverse of x. So the integral 1 upon 2 x square tan inverse of x minus 1 upon 2 x plus 1 upon 2 tan inverse of x plus c is the integration of the given function. Or you may take 1 upon 2 common from each of these. Now the example is x square into tan inverse of x. Use by parts. The inverse trigonometric function will be your first function and x square is the second function. First function as it is integration of the second function minus d by integration of d by dx of the first function into integration of the second function. Now we know that derivative of the tan inverse of x is 1 upon 1 plus x square and integration of x square is x cube upon 3. So what you get is 1 upon 3 times integration of x cube upon 1 plus x square. Call this as I1. Okay, so I1 is x cube upon 1 plus x square. I can write it as x square upon 1 plus x square into x dx. So I will use the substitution 1 plus x square is equal to t. So x square is equal to t minus 1. Therefore x dx is equal to dt upon 2. So use that substitution here. You get 1 upon 2 integration of 1 minus 1 upon t dt. So integration of 1 is t and the integration of 1 upon t is a log of t. Okay, so the I1. But what is t? T is 1 plus x square. So we will put that t 1 plus x square here and then using I1 in this I integral, I is equal to 1 upon 3 x cube tan inverse of x minus 1 upon 6 times 1 plus x square minus log of 1 plus x square plus c, where c is minus 1 upon 3 times c1. This is the integral of the given function. Now the next example is x cube tan inverse of x. If you see these last three examples, first is x tan inverse of x, the second is x square tan inverse of x, and the third is x cube tan inverse of x. So let I is equal to x cube tan inverse of x. So using LIATE rule, rewrite the function. Then using by parts, first function as it is, integration of the second minus integration of the derivative of the first function into integration of the second function. So after applying the laws and the rules of the integration, 1 upon 4 times integration of x raised to 4 upon 1 plus x square dx. Now here we can write this x raised to 4. Here the degree of the numerator is more than degree of the denominator, because so here actually we can divide the numerator by 1 plus x square. Okay, so we will actually divide the numerator by this 1 plus x square like this: x raised to 4 divided by x square plus 1. So x square into x square, x raised to 4 plus x square minus, you will get 1, only x square, then minus 1 into x square minus 1, so this also gets cancelled and you get 1. So I can write this x raised to 4 as x square minus 1 into x square plus 1 like this. Then we will divide 1 plus x square separately. Integration of x square dx minus integration of dx plus integration of 1 upon 1 plus x square. Its integral is tan inverse of x, its integral is x, and integral of x square is x cube upon 3. You can take 1 upon 4 common, or you can multiply this bracket by 1 upon 4. So 1 upon 4 tan inverse of x into x raised to 4 minus 1 upon 12 x cube plus 1 upon 4 times x plus c. Now look at this example: log of x bracket square dx. Let I is equal to integration of log of x bracket square. So here you have to use the substitution: log of x is equal to t. So we can write this equation as x is equal to e raised to t, using property of the logarithm. This is logarithmic form, this is exponential form. Then dx is equal to e raised to t dt. So using LIATE वापरला तर t square is the algebraic function and e raised to t is the exponential function. So keep first function as it is, integration of the second minus integration d by dt of the first function into integration of the second function. So t square e raised to t minus integration of 2t into e raised to t dt. So t square e raised to t minus 2 in bracket into integration of t e raised to t dt. Again I will use here by parts. The first function as it is, integration of the second minus integration of d by dt of the first function into integration of the second function e raised to t dt. So integration of e raised to t is e raised to t and derivative of t is 1. So 1 e raised to t, and integration of e raised to t is again e raised to t. So I is equal to t square e raised to t minus, multiply this bracket by this 2, you will get minus 2t e raised to t plus 2 e raised to t plus c. Now here you can take e raised to t common, or you can keep it as it is. We have to use value of the t. What is t? T is log x. So log of x bracket square, and e raised to t is nothing but x. So x log of x bracket square minus 2x log x plus 2x plus c. Now these three terms contains x, so I can take x common, x times the bracketed term. Now sec cube of x dx. Here we will write this sec cube x as sec x into sec square x, and then we will use the by parts. First function as it is, integration of the second minus d by dx of the first function into integration of the second function. Now this integration of the sec square x dx is tan x, and the derivative of sec x is sec x into tan x. So you get sec x into tan square x. But what is the value of tan square theta? It is sec square theta minus 1. So I will use that value here. Then again multiply this bracket by this sec x. You get sec cube x dx plus integration of sec x dx. But sec cube dx is nothing but our integral I. So I is equal to sec x into tan x minus I plus log of modulus of sec x plus tan x plus c. Therefore 2I is equal to sec x into tan x plus log of modulus of sec x plus tan x plus c. Now what we can do? Now we will divide this equation by 2, 1 upon 2 times this. So this is the integral of the given function. X into sine square x dx. Now here LIATE, after using that, you can see this sine square theta. We don't know the integral of sine square theta, cos square theta, but we know the formula to convert that into double angle formula. That is 1 minus cos 2 theta upon 2 is nothing but sine square theta. So use that. 1 upon 2 is a common. So in bracket x minus x cos 2x. So take the separate integral. Integration of x is x square upon 2 and integration of x cos 2x. Here we have to use the by parts. First function as it is, integration of the second minus dy dx of the first function into integration of the second function. So 1 upon 2 in bracket x square upon 2 minus x into sine 2x upon 2 minus integration of 1 into sine 2x upon 2 dx. So I is equal to 1 upon 2 integral of x square upon 2 minus integration of x sine 2x upon 2 minus 1 upon 2 sine 2x dx. So what we will do? Just multiply this 1 upon 2 to this bracket. You will get x square upon 4 minus 1 upon 4 x sine 2x minus 1 by 8 cos 2x plus c. Now the 10th example, e raised to integral of e raised to 2x cos 3x dx. So I is equal to e raised to 2x cos 3x dx. Now in this case, this is exceptional case. We don't have to choose the first function or second function to evaluate this type of function. E raised to x cos bx plus c or e raised to x sin bx plus c. These are the exceptional cases for by parts. So here, keep first function as it is, integration of the second function minus integration of d by dx of the first function into integration of the second function. Now cos of 3x into this integral of e raised to 2x is e raised to 2x upon 2. Cos derivative of cos 3x is minus 3 sin 3x. Then integration of sine 3x into e raised to 2x. So again here we have to use the by parts rule. Take that integral as I1 and we will solve it by using by parts. How? This I1 is first function as it is, integration of the second function minus integration of derivative of the first function into integration of the second function. So I1 is equal to sine 3x e raised to 2x upon 2 minus integration of bracket 3 cos 3x e raised to 2x upon 2 dx. So here we can take 3 by 2 common and then we will get e raised to 2x cos 3x dx. But it is nothing but our original integral I. So we replace it by I. This is our I1. Now I will use this I1 in this our I. So I is equal to 1 upon 2 times e raised to 2x cos 3x plus 3 by 2 in bracket 1 upon 2 e raised to 2x sin 3x minus 3 by 2 times I plus c1. Now multiply this bracket by 3 by 2. You will get minus 9 by 4i. Take this term to this side and 3 by 2 c1 as a c or okay. So you will get here 13 by 4 times I is equal to this. Now divide, take this 13 by 4 to this side, multiply divided by 4 by 13. I is equal to 2 upon 13 e raised to 2x cos 3x plus 3 upon 13 e raised to 2x sin 3x plus 2 upon 13 times c1. So in next step, I will call this 2 upon 13 c1 as c. So and take each 1 upon 13 e raised to 2x common from these two terms. Okay. So this is the first lecture on the exercise 3.1.